to all our viewers. I'm Miraculin Lydia, and I'm an occupational therapist working at PlayStreet, Bangalore, India.
Hi everyone, I am Mini Dwivedi Gopinathan and I am the founder and director of PlayStreet, Bangalore, India. I am a RDI consultant and I integrate my work with sensory motor approach, trauma sensitive practice, and polyvagal theory. PlayStreet is an organization that provides educational services to help the child with special needs become independent and live up to his or her potential. We offer parent empowerment programs and integrated schooling programs and a variety of clinical services. In recognition of Autism Awareness and Acceptance Month, our focus is firmly set on the profound significance of dyspraxia. We aim for this series to shed light on the complexities of dyspraxia, address the specific hurdles people with dyspraxia face, and raise awareness about its importance within the neurodiversity movement. Today, we are on the fourth talk of our series under the segment which focuses on unraveling dyspraxia, exploring connections with autism and the brain. The topic for today is neurological correlation of dyspraxia, the role of primitive reflex integration. And we are honored to have Ms. Sally Goddard Blythe with us to share her valuable thoughts and information on the same. Let me introduce our great speaker to you today. Ms. Sally Goddard Blythe is the director of the Institute for Neurophysiological Psychology, INPP. She has written 8 books on children's motor development, including the go-to book on childhood reflexes. INPP was established in 1975 to develop assessment procedures for identifying physical factors in learning difficulties and underachievement. Sally's primary work involves clinical practice supervising INPP programs with children and their families. In 1996, she developed the INPP screening test and developmental movement program, which has been widely used in schools worldwide. Sally has also standardized training materials for INPP approved courses, making it accessible in 14 countries. Sally has lectured and provided training on infant reflexes in development and later learning problems. She has authored several research papers on the incidence and impact of immature neuromotor skills on development and educational achievement. Her current work focuses on private practice, lecturing, interviews, research, and consultancy. Ms. Sally, we are very grateful that you have taken time out of your schedule and really busy schedule to share your knowledge about dyspraxia and its impact on the various parts of a child's life. Before we begin, would you like to share any thoughts to our viewers?
Well, first of all, thank you for inviting me to join you. I feel I should make it clear from the beginning that dyspraxia is not my area of speciality. My area of speciality is neurodevelopmental problems in general and the motor implications of those problems. So I want to put into context the sort of discussion we're going to have today to say that I will look at dyspraxia within that broader framework of neurodevelopmental disorders.
Sally, first of all, really, we are thankful to you that you accepted the invitation to talk on this subject. And secondly, your perspective is so important for us to bring it here. So when we're talking about dyspraxia, we just cannot talk on dyspraxia. We have to bring so many related frameworks and perspectives to put everything together. So yes, it's an honor that you are here and you are helping us to look at the other areas and frameworks and perspectives too, for us to even understand that, okay, how even those areas are also impacting when children are diagnosed with autism and dyspraxia. Okay, so let's get right into the questions. So my very first question is, and I would like to definitely take this question from your expertise, which is primitive reflexes. So how do primitive reflexes play a role in the neurological correlation of dyspraxia?
Well, as I have just mentioned, we see dyspraxia as one of a group of neurodevelopmental disorders, of which other ones are things like ADHD, autistic spectrum disorder, dyslexia, and so on. And each one of those disorders have their own specific criteria but there is also a comorbidity in terms of some of the motor factors that underlie all of them. So, for example, we know that up to 80% of children diagnosed with dyslexia have some symptoms in common with children with dyspraxia. That up to 90% of children diagnosed with dyspraxia have some dyslexic type learning disabilities, but they are not specific enough to be categorized as true dyslexia. And that we see aspects of attention difficulties, autistic traits, and so on in all these different groups. And if we were to draw a Venn diagram of sort of three of those, where the intersection is, that's where the common denominators of underlying immaturity in some of the neuromotor skills is shared in common by all. And when we look deeper into that as to what other common factors are there, we find that the retention or persistence, not retention, persistence of some primitive reflexes is present in many of them, together with underdeveloped postural reflexes, which collectively provide the basis for the control of posture, balance, equilibrium, and even eye movements later on.
That is such an important information for us to know, that the deep down difficulties are so many for us to see the difficulties which we actually see. And do not know the underlying difficulties. And as you have said, the intersection of the Venn diagrams is the beginning point of those underlying difficulties. So what are the neural correlates of dyspraxia?
Now that's $1 million question. And I have searched, I've done quite a literature research over the last couple of weeks to see if I can, pick up some of the latest research on this. And the general consensus in the literature that I've looked at is that no single locus has been identified, a neural signature, if you like, a specific region of the brain that is consistently present in individuals diagnosed with dyspraxia. So a study that was carried out in 2016, which was a sort of meta-analysis of neuroimaging studies done on individuals diagnosed not with dyspraxia, but with developmental coordination disorder. And these two terms are often used interchangeably. If we were to try and separate out what is one and what is the other, in professional terms, developmental coordination disorder is a recognized medical condition, and therefore more scientific research generally has been carried out on developmental coordination disorder rather compared to dyspraxia. So this study, this meta-analysis was done on individuals with diagnosed with DCD, and their conclusions were, while several brain areas were implicated, including the basal ganglia and parts of the frontal lobe, perhaps the most important part was connections between these regions, specifically corticostriatal and corticocerebellar circuits. But their conclusions were that the research was too sparse, there were too many limitations in the studies in terms of individual differences to find a clear neural signature for developmental coordination disorder. I don't know whether you'd like me to touch on the parts of the brain that they identified, what the functions of those parts of the brain are, or whether you would like to just...
Yes,
okay.
I would like you to touch on that.
So cerebellum is important, particularly in my field of work, because it's involved in many tasks, but particularly the regulation and fine-tuning of motor output, including things like the timing of muscle actions and coordinating movement, the final stages of coordinating eye movements that are needed for things like reading, writing, catching a ball, and so on. Helping the body to learn movements. So, for example, if you were learning to play a piece on the piano, when you first started to learn that piece, the first sort of 2 or 3 practice sessions, the cerebellum would be very active and very much involved. And as that practice becomes more perfect, the cerebellum becomes less involved as those skills are automated. And it's also thought to play a role in the regulation of emotion as well. So the cerebellum is very important as a sort of central coordinator of the final stages of output. Then the basal ganglia, which acts as a gatekeeping mechanisms for the initiation of motor movement, effectively choosing which actions to allow and which to inhibit or which to suppress. The specific areas of the frontal lobe, the motor cortex and the association cortex, these are areas that plan voluntary actions, coordinate sequences of movements, make decisions about proper behavioral strategies and choices, evaluate the appropriateness of a particular action in the context of the environment, and relay commands to the appropriate sets of lower motor neurons to execute the desired action. So this is the sort of executive planning part of motor coordination, which then relies on the lower centers to be able to follow through what it wants to do. And the cortico-striatal connection, which this particular method plays a central role in developing appropriate goal-directed behaviors, including motivation and the cognition to develop appropriate actions to obtain a specific outcome. So each one of those areas was implicated, but not consistently across all cases. So from my point of view, from a therapeutic point of view, we are looking quite often at the functional connectivity between these different areas and saying, if we can improve that by using movement programs, do we then reduce the symptoms of dyspraxia? I would never use the word cure and I would never use the word prevention, but ameliorate perhaps is a better one to use. So then I looked to see if there was anything more recent, and there was a review of literature carried out in 2022 that also looked at what had been found. Large-scale review, really, over 100 papers are based on individuals with DCD, and 1,374 cases within that. And their conclusions were more to do with symptoms, really. The symptoms were things like voluntary gaze control during movement, which I'll come on to a little bit later, why the primitive reflexes may be involved in that. Cognitive motor integration, practice or context-dependent motor learning, which we just touched on a little bit, the possible role of the cerebellum in that. Internal modeling or ideation of movement, more variable movement kinematics, and larger safety margins when locomoting. So what we see in these individuals is that their personal space is actually larger than normal in terms of their physical control of operations. They need a wider range or a wider scope within which to operate, which also has implications for their social and peer relationships, because personal space is the beginning of social interaction, of knowing where is comfortable for you in relation to someone else, and so on. So other things they picked up were atypical neural structures and function across sensory motor and prefrontal regions. And so taken together, the major deficits they felt were in visual motor mapping and cognitive motor integration, abnormal maturation of motor network, really, and areas of pragmatic compensation for motor control deficits. In other words, the ability to self-correct when they know a motor action hasn't been as precise or appropriate as they would like it to have been. So that is, as far as I am aware, where we are in terms of neural structures that are implicated in dyspraxia, but they still don't explain why. They simply talk much more about the what.
Yes, and while you were talking, I was seeing that how so many approaches are required to be integrated when we engage with the children. So,
Yes.
like primitive reflexes, if we have to work on. So there's a lot of sensory component coming in, motor component coming in, and a lot of co-regulation component, relationship component, the social engagement part, right?
Yes.
So that is coming in, and then the ideation part is coming in. So it's not just about I ask you to do something, I teach you something, and you just imitate and learn.
No.
Right? More than that, the ideation and then the planning, which is basically the deficit in dyspraxia and of course in autism too. But the reasons for it to happen are so many, and which you have beautifully explained. And that too, you have really simplified. You used a lot of technical terms, and but still the way you presented it was much more simplified for our viewers to understand that the challenges are really deep down. So the kind of work also needs to be pretty integrated. not just one area of work will help. And that's the whole reason why we want to bring this topic in the summit.
Yes, yes.
Okay? So let's move to the next question. Why is abnormal maturation of motor networks important?
In normal development, the first 18 months of life are characterized by really spectacular development in our ability to cope with the demands of gravity. So the main tool we have as living beings to counteract the effects of gravity is the development of muscle tone, agonist and antagonist muscles as anti-gravity forces.
Yes.
And they, together with development of balance, postural control, and equilibrium, provide the basis for a child's ability to physically explore space. And the physical exploration of space is the precursor to being able to then handle space obstacles and things from without the self rather than from within the self. So if there is a delay in the physical process of becoming competent as a moving being in space, a physical moving being in space, it potentially undermines all those higher skills that depend on that physical stability, security, and confidence and competence in the use of space. I think it was beautifully described by Ray Barsh in the 1960s, who described the young child as being a terranaut, not a terrorist or an astronaut, but an astronaut on terra firma. He said that the child's first challenge is to become confident and competent in the use of space. And that begins in infancy at about 6 to 8 weeks of age with the ability to start to hold the head up. That head control starts to work down the body through the neck to the upper trunk. It then works from the bottom upwards towards the core and eventually should meet in the middle so that a child is by around 12 to 14 or 16 months of age able to stand with free use of the hands to develop those skills that are uniquely human, those manipulatory skills and so on. But if the arms and the hands are still needed to support control of balance, that child does not have the full support in terms of motor skills to be able to develop the more complex skills higher up.
And as you mentioned that until and unless the child knows his body into the space, which happens in certain early infancy, the rest of the development really gets affected.
Yes, it's literally as if there are pieces of motor vocabulary missing later on. And so the ability to use the body, the language of the body also becomes impaired.
And not only the motor movements are affected. So when I'm not very comfortable about my body, or if I do not know the language of the body, or I do not know my body, even my social engagement and my confidence about myself, and that all gets affected.
I mean, one of the things we look at when we assess children is the draw a person test, which I'm sure you are familiar with.
Yes.
And I would say almost without exception, the children we see, their mental age performance on that test is 2 years behind their chronological age before we start working with them physically. And it's not just the scoring of the draw a person test that's interesting, it's actually what they do with the drawing of the human figure. Because children with motor issues, not necessarily dyspraxia, but particularly in dyspraxia, will either leave off parts of the body in their drawing that are not working well for them, or they will represent them disproportionately to the rest of the body. So the head may be extremely large, the hands very small or not shown, the feet enormous, which suggests that there is a need for greater proprioceptive stimulation or feedback from the feet to tell the brain where they are in space, that the head feels huge, but the body doesn't feel adequate to support the needs of the brain and the thinking brain and so on. And so we see that represented in the draw a person figure. And when they've been through a movement program, the human figure has become much more detailed. The proportions are usually better, but the social relationships of those children have often improved as well. Because as you say, when the body language is restricted, the ability to read the body language of others correctly is also compromised. And so they don't know when they're standing too close, when to back off from a situation, when to join in, how to join in, and so on. And that awkwardness makes them tend to be rejected from socially by the group.
And how amazing is that we are using child's communication about his body to assess him.
Yes.
I
Yes.
mean that whole idea itself is so amazing that it's so that every input my child is giving is so personalized, and it could be
Yes.
so unique what the way he's feeling his body.
Yes.
So I mean, yes, this is really some of the great works which you are really helping us to understand here. So let's move to the next praxia, and how do they relate to primitive reflex integration?
Okay, so briefly, let's have a look at dyspraxia, DCD, and then I'll go on to the primitive reflexes so we can sort of
Okay.
see the three categories and the context in which they fit. So well-known, well-recognized signs of dyspraxia are things like difficulties with posture, balance and movement issues, abnormalities of gait, how do children stand and walk, difficulties with hand-eye coordination, fatigue because they use up more energy than is actually technically necessary for carrying out a specific task. So it's energy inefficient and therefore more exhausting. Trouble learning new skills and difficulty applying already known skills to new situations, that adaptation and flexibility. Organization and planning problems, difficulty writing or using a keyboard, struggling with aspects of self-care, and a tendency for the two sides of the body to want to mirror each other in movements instead of one side of the body being able to work independently of the other, and overflow movements where parts of the body that are not necessary for the task all become engaged in trying to carry it out. So those are the sort of well-known features of dyspraxia. We look at DCD. Specific things are things like the voluntary gaze control during movement, which, as I mentioned earlier, I will come on to the connections with primitive reflexes to that. Cognitive motor integration, practice context-dependent motor learning, internal modeling, which is the sort of ideation we talked about before, larger safety margins when moving, and atypical neural structure and function across sensory motor and prefrontal regions. So that again is the what. So now let's have a look at how and why primitive reflexes may play a part in that. So primitive reflexes are a group of little reflexes that are present at birth in the normal infant who's born at full term. So parents will recognize things like if you stroke down one side of the face, the baby's head will turn and it will start to nuzzle or root, searching for the breast or the bottle. If you place something in the palm of the hands, the thumb will come across the fingers over the top and it won't be able to let it go. So we've all sort of seen these little reflexes at work. But over the course of the first 6 months of life, as connections to higher centers in the brain or from higher centers in the brain develop, which they do very quickly, those little primitive reflexes should no longer be necessary to protect us. So they are inhibited or put to sleep in the brain stem, only to be reactivated again if there is accident or injury to higher centers. So they never entirely disappear. They are simply inhibited as more advanced and sophisticated abilities develop. And at the same time as they are becoming inhibited, a new group of reflexes called postural reflexes or reactions start to develop, which collectively provide the basis for control of head on the body, control of balance, posture, and movement in a gravity-based environment at a subconscious level. So we don't have to think about how do we sit, how do we stand. That's what the postural reflexes should do for us. But sometimes, and often we don't know the reason why, that full integration process from primitive reflexes being put to sleep and postural reflexes developing by 3.5 years of age does not take place as completely as it should. In severe cases where there is brain damage, such as cerebral palsy, those primitive reflexes would be diagnostic signposts of the area that has become damaged. They will never be completely inhibited. But what we see in our area of work is more subtle presentation of this, where cerebral palsy isn't present, but the primitive reflexes have not been as completely inhibited as they should have been, and some of the postural reflexes have not fully developed. So these children are not bad enough in terms of their symptoms to have received a formal medical diagnosis, but neither do they have all the tools in place that they need to support control of balance, posture, movement, and so on later on. And so we call them grey area children because they don't quite fit neatly into anyone's category. But if that occurs, then the primitive reflexes start to interfere with the relationship between higher centers in the brain, intention of movement, and what the body actually does in return. So the brain knows it wants to carry out a specific movement, but when the head is turned or flexed or extended, depending on the reflex, the arm or the legs do something different from that intention. And then the feedback back to the brain is not what the brain expected. And if that feedback is faulty, however hard the thinking part of the brain wants to control it, it can't refine it because the relationship between intention and performance is not what was anticipated. So these little primitive reflexes act like spokes in the wheel of a bicycle wheel turning. The wheel is fine, there's nothing wrong with it, but something, a specific type of movement, interferes with that relationship between intention and performance. And no amount of practice of the action seems to improve it.
Yeah, this is, I mean, everything is so interconnected, and changing that one thread in isolation is really not easy.
No.
Even identifying it is also not easy. So I understand the enormity of this subject. Okay? And it differs for every individual.
Sorry, I missed the last part of your sentence
And
there.
I mean, it differs for every individual. The reason might differ for
Yes.
every individual, though the symptom which we are seeing might be the same.
Yes. And this is where the primitive reflexes are useful tools in clinical practice. And this is how we use them. I don't say we treat primitive reflexes. I say they provide us with information in clinical practice so that you can carry out the assessment of these reflexes together with other motor tests, motor proficiency tests, eye movements, and so on. And you will get an individual profile of reflexes in every single person you see. It will never be exactly the same twice.
Yeah.
Although the diagnosis, which is the description of symptoms they've come to you with, may be the same. And
Yeah.
it's that profile of reflexes that informs us as to what stage in development do we want to start an intervention program? What type of movements do we want to use? Do we want to mix sensory stimulation with a motor training program? And it's those reflexes that give us the key as to what, where, and why we're going to start a program. And they also provide measurements of progress as someone is going through a program. So come back, you can retest those and say, has the intervention I gave made a significant difference to these reflexes or not? And if it hasn't, it indicates that what we're doing is not the most appropriate intervention.
And that is the most scientific way of doing the clinical practice.
I hope so.
Yes, yes, yes. Right. So let's move to the next question. Can you explain the neurological mechanisms underlying dyspraxia and its connection to primitive reflexes?
I can give you some examples because, as you said, it's so complex. So I think perhaps the most useful one to understand is how do primitive and postural reflexes influence centers involved in the control of eye movements? Because that then has a follow-on effect on things like reading, hand-eye coordination, even visual perception, whether a child is seeing the same as you and I see when it looks at print on a page or shapes on a page and so on. And this can perhaps best be understood by the interrelationship between three interconnecting loops. The vestibular cerebellar loop, so that describes the balance mechanism. The vestibular system is the balance mechanism located in the inner ear, and its relationship to the cerebellum, that little brain that's involved in the fine-tuning of motor coordination and integration. So we have one which is a vestibular cerebellar loop. We have one which is a vestibular spinal loop, which is from the vestibular system directly down to the body and back again. So this is the relationship between balance going down and proprioception coming back. And the main junction for that functional relationship is at the neck. Certain primitive reflexes, such as the tonic labyrinthine reflex, symmetrical tonic neck reflexes, and so on, are activated as a result of movement of the head, either flexion, extension, or lateral rotation. And if that reflex is present, it will alter what was expected in that relationship between vestibular system sending the information down, saying this is what I want you to do, and the proprioceptive information coming back, because the reflex will cause the body to do something different from what was expected. So that vestibular spinal relationship can be influenced by the integration or otherwise of primitive reflexes, and it then interacts with the vestibular cerebellar system to fine-tune movements. And another loop, the vestibular ocular reflex arc, depends on the stability of those two other loops in order to function efficiently. So if there is a problem at the vestibular spinal level, the postural cerebellar part has to work harder to try and fine-tune things. The postural platform on which eye movements depend is unstable. And we can predict at that stage, when we come to test eye movements, things like tracking movements will be erratic, hand-eye coordination will be underdeveloped, even visual fixation and figure ground problems can be present simply as a result of postural reflexes, head writing reflexes being underdeveloped, and tonic neck reflexes still being active when they shouldn't be.
That is so good to know that posture plays such an important role for us to support with so much of higher function which we do. And it seems to be so, we don't forming that connection, that posture is responsible for so many things like vision, like saccadic movements or convergence or divergence. Making this correlation is not easy. People just think I'll work on the eyes and things will get better, or I'll just work on the speech, I'll work on the motor areas and the speech will come. I'll work on some language related issues and the language will improve. But that's not how it happens.
And often the presenting symptoms can be misleading. So one of the things we get children to do is the tandem walk, walking one foot in front of the other, heel touching the toe, going forwards and going backwards. When I am teaching students, I get them to try this first, and we look at what their baseline performance is. And then we put some distortion glasses onto them, the students, and we get them to do the tandem walk again. And a student who was perfectly able to place their feet correctly and control their balance the first time, when distortion glasses are put on, cannot locate where the toe heel position is, show signs of dysnergia in placing their foot. And it would be very easy to look at that symptom and say, oh, we have a cerebellar problem here in terms of plate. But the problem that we have created is a disassociation between the visual system, the proprioceptive system, and what it's used to. And so, what we see as a symptom is not necessarily the obvious cause of the condition we're trying to treat. It is so much more complex than we know really.
So when a child who would be having this kind of issue, we don't even realize how much work his eyes are doing, which eyes are not even meant to be doing. So,
yes, exactly.
Right?
Yes.
So look at the child overwhelmed. The visual system is so overwhelmed and doing so much of extra work, which otherwise vision system is not even supposed to do.
Yes. And then they become overloaded very
Yes.
quickly. And you
Yes.
start to see emotional symptoms, behavioral problems, because this
Yes.
child cannot cope with this amount of compensation.
Yes. That's true. I hope that audience who's watching this interview really understand this and take this message and really try to integrate these practices into the child's treatment.
Mm.
So with that, we move to the next question. What are some of the common primitive reflexes that are often implicated in dyspraxia, and how do they impact motor coordination?
Okay, well, I'll give you 2 or maybe 3, depending on how much time we've got. So
Okay.
the one that's, I think, very clear is the asymmetrical tonic neck reflex, which every mum will remember. So that somewhere around 18 weeks in the pregnancy, she'll have said that the baby started to kick. In fact, the baby's been kicking her for weeks before that, but she becomes more aware of it as the baby gets bigger, the movements become more stronger and more robust, and the reflex itself develops. And what it is the baby's all curled up inside mum's tummy. But when the baby turns its head to one side, the arm and leg on that side try to straighten within the confined space, and the opposite ones try to flex. And so that movement is felt sometimes as quite a powerful kicking or punching movement. And that reflex should get stronger so that it's fully active at the time of birth in a full-term baby. And it is suggested that it's the earliest eye-hand coordination training hardwired into the brainstem at birth. Because babies at birth are a little bit like me before I had my cataracts done a couple of years ago. They are very short-sighted, myopic, and they can only focus at about 15 to 17 centimeters from the face. And what they see is nothing like what you or I see. They see outlines, not internal detail or features. They see contrast, they see bright lights, they see colors, and they are highly what we call stimulus bound. And the eyes and the brain have got to learn how to work together to make sense of the visual world. And this little mechanism ensures that when the head turns, not only does the arm and hand extend, excuse me, but the eyes are also locked into the arm movement. So they help to extend baby's focusing distance from near point to arm's length and back again, from central vision to peripheral vision and back again. And a few days or weeks later, really as a result of accident, that hand or arm may come into contact with a solid object. So through a combination of turning the head, seeing, touching, and the proprioceptive feedback derived from the movement of the arm, the brain and the eyes start to understand better distance, timing, depth, and so on. So this little reflex has a purpose in those first few weeks of life, but rather like a guest that was invited to stay with you for 3 days, who's still with you weeks later, it's not quite so welcome if it's still active when a child's sort of that much older and going to school. And one of the first casualties is usually something like hand-eye coordination and handwriting, because as long as the head is in the mid, it's centrally placed, there's no problem. But if the child starts to turn their head to follow what the writing hand is trying to do, this arm actually wants to extend and the fingers want to open. So they have to find a way of controlling the implement. It may be how tightly they hold it. It may be the type of pen grip they use. It may be the position they sit in or how they have the paper rotated. Anything to enable them to write with an arm that wants to straighten. And that then affects not just the physical action of writing, but often the ability to transfer information cognitively from here, the brain, down onto paper, because so much effort goes into trying to control an arm or a hand that doesn't want to do what the brain would like it to do. It can also affect the ability to cross the midline of the body if the head is turned to the affected side. And so things like bilateral integration start to become affected and so on. So that's one example. Another is something called the Babkin reflex, which is like the combination of 2 reflexes working together. So we talked about the little rooting reflex that the baby has. When you stroke down one side of the face, the head will turn, the mouth will open, and start searching for the breast or the bottle. And that will then initiate sucking when something is placed in the mouth. And the little palmar gripping reflex in the hands. The Babkin reflex is like a connection between the hand and mouth that exists in the first weeks after birth, where sometimes if perhaps a baby is having difficulty latching on and suckling, a midwife will massage the palm of the hand or even the soles of the feet, and it will activate this little reciprocal link, which makes the hand close. And when the hand closes, the sucking movements start to be initiated as well. So there's a connection between the hand and the mouth in that early feeding stage. But that should become uncoupled somewhere around 9 months of life, so that you can do something with your hands without your mouth having to mirror what they're doing, and vice versa. If traces of that reflex are still present, we will often see when children try and carry out fine motor tasks, the mouth or the tongue follows, mirrors the movement of the hands. And when they try and do something with the mouth, they can't keep their hands still. So we are getting this overflow of movements that are not actually essential to the task in hand, and are also preventing that child from being able to multitask, because two systems are involved in a single task when only one system is needed. So those are just sort of two examples really of how individual reflexes can affect function. And in the children we are working with, we're looking at a cluster of these, not necessarily fully retained as in infancy, but little traces of 3 or 4 of them that impact different areas of functioning, and then in combination start to have a much bigger impact on motor related skills generally.
Such an important aspect that you have explained. So now I would invite Miraculin to ask the further questions, because Miraculin has recently taken a certification in primitive reflex integration.
Okay.
And she's very interested in this subject. And she is really able to connect, being an occupational therapist already.
Yes.
So I want that Miraculin should take the interview forward. Yes, Miraculin,
Okay.
next question over to you.
Ali, so your information that you've given is so good that I can actually, see what we are seeing in our children, especially when you spoke about the ATNR and Babkin and all that is some of the very common reflexes that we see in literally every children who come here. So we see because of that, they have a lot of motor issues, fine motor issues especially, and also feeding issues because of Babkin present and all of that. So till now, we've been talking about the neurological pathways behind primitive reflexes and what are the primitive reflexes. So I would like to hear your thoughts on how, as professionals, we can help integrating these reflexes, like from a dyspraxia point of view. So because I feel like working on the primitive reflexes will contribute a little to manage the dyspraxia symptoms.
Yes, and as I'm sure you're aware, there are many different programs that claim to integrate primitive reflexes. Some are of quite short duration, some are more like general motor training programs, some are more like sensory motor integration programs, and all have their place. So I'm only really going to talk about what we do, because that's the one that I know most about. So ours possibly differs from some of the others in that we take children back in time motorically to replicate movements that in theory should have been made during the first year of life. And often we do not know whether they were or they weren't, or why they may have been missed. But as a result of 1 or 2 missed stages of development, those neural pathways, or the neural pathways that have developed, just don't seem to be as efficient as they could be. And by taking them back in time and practicing not skills, but actually very, very simple infant movements, you seem to be able to rewire the system to work in a more efficient manner, so that we are not necessarily looking at specific dyspraxia symptoms and saying, let's give you a physical program to improve that skill. we're saying, okay, well, which reflexes are present? What is the sensory system that triggers that reflex? So it could be it's a vestibular problem. Let's look at which type of vestibular stimulation is likely to reduce the reaction of that reflex. And if that vestibular stimulation doesn't do it, then we may have to use the reflex itself as a way of helping to integrate, which might be a stimulation followed by an integration exercise, followed by an inhibition exercise. And so this is where the assessment of the reflexes is really useful, because you look and you say, which is the earliest developmental reflex that's abnormal? Okay, that's our starting point. Which is the earliest sensory system linked to it? Right, that tells us where we need to begin in terms of sensory stimulation. This is where we need to begin in terms of replicating movements. And I have to say, our system is not a quick fix miracle solution. It works on the basis of three things being there together. Repetition, that they do that exercise every day for several weeks or even months before it's changed. Regularity, so that's the daily part, and duration, that they do the program for long enough on a daily basis, not just to get better at the movements, but to make a change to the underlying neural pathways that support those and a whole range of other movements. So we reckon on an average of a year, during which we will see those children in practice every 8 weeks, and the parents will do the exercises at home on a daily basis. So it's a long-term commitment for the family, really.
This is a very different approach to what I have learned or what I've seen. Also, because one thing what came to my mind when you were saying this is most of the children that I've seen here who have the symmetric tonic neck reflex persistent. The most common things that I've heard the parents say is that my child went from sitting to standing and walking. So they
Yes,
skipped the crawling phase. So when
yes,
I hear that, and I can very much correlate that, the children who have skipped the crawling phase has a persistent STNR present, because that
yes,
up and down movement of the head, which is not integrated, and you can still see the uh, problems because of that persistence. So I think what you have mentioned is a very good and a direct approach, like going back to the primitive phase and working on what they have missed and all. Thank you so much for that. Also, what do you say about the advancements in neuroscience that contribute to our understanding of relationship between dyspraxia and primitive reflexes?
Well, as far as I'm aware, there is a paucity of research on dyspraxia and the relationship between primitive reflexes. There's one small piece was done in 2015 by a group of Swedish researchers that looked at balance and dyspraxia and suggested that primitive reflex testing should be part of dyspraxia assessment in the future. But generally speaking, most of the literature is looking more at things like ADHD, autism, speech and language disorders, and so on. So there is very little large enough scale research on dyspraxia and the relationship between primitive reflexes. And there are two ways of doing it. One is using, sort of motor assessment test batteries alongside primitive reflexes, and seeing do you get improvement not only in the reflex tests, but in the motor assessments and so on. Functional imagery would be a great tool in the future, but also things like electromyography, looking at muscle tone testing, and even EEG analysis. A colleague of ours in the States did a very small pilot project where he was using neurofeedback, EEG for neurofeedback, and he was using a reflex integration program with some patients and an INPP program with others. And then looking at the EEG before and afterwards. And what he was able to show, excuse me, was that levels, centers in the brain involved in arousal and hypervigilance became much more regulated and much more normal following the reflex integration program. So there are lots of different tools of measuring, but generally, yes, much more research is needed now, looking specifically into dyspraxia or DCD and the incidence of primitive reflexes. That's part one. Part two is whether in individuals with that diagnosis, you can significantly integrate those reflexes. And thirdly, if you do integrate those reflexes, do you get a crossover into improved performance in other areas of functioning? So there's a whole series of PhDs there waiting to be done.
That is actually true, because like there is very the research also is very less as to uh, what do you say, like there are the number of researchers are very less which has looked into primitive reflex integration and improved performance, because so far the researchers that I've read, they all have done in the aspect of education and studies, but not much in motor movement or functional activities. So yeah,
Yes.
I think we will require more research. Also, like there is no specific objective test, I think, for a primitive reflex retainment, because so far whatever I've seen, it's all subjective. Like you see
Yes.
how much it's present, also, so there's no objective scale as such. So that is also
We have
something
we
I think.
have tried on our assessment tools and
Okay,
publications, we use a 0 to 4 rating scale
okay.
for each reflex. So 0 always means no abnormality detected, and 4
Mhm.
means that it's fully retained as if in a newborn infant. And your 1, 2, and 3 is like traces of it.
Okay, okay, yeah.
But that does need to be validated, that scoring tool. And that's another area I think in much need of, we can look at it and we can say, look, empirical evidence has shown this over many, many years and many thousands of children and different researchers, but that tool still needs to be validated to make it an acceptable measure, I think.
Yeah, that is true. I think we will require an objective measure to very clearly say that this is how much of primitive reflex is retained. And so I think that would be much more useful.
Yes.
So thank you, Sally, for that. And I know you had mentioned previously while doing the interview that you don't really use the term prevention. But for the upcoming question, I just wanted to know, can dyspraxia be effectively managed or prevented through early intervention targeting primitive reflex integration? What are your thoughts on that?
Prevention, I think I don't know whether it can or it can't. Again, because there are so many different reasons that someone may have received a diagnosis of dyspraxia. I think the majority there is an underlying immaturity in the functioning of the central nervous system that is intrinsic. But equally, there can be environmental and experiential factors that have contributed to that. So we have the dual processes of maturation and physical experience. And maturation should unfold naturally, but it is also interdependent with physical experience. So I can remember a child I saw many years ago, a little girl of 12 years old, who had been adopted in the United Kingdom from one of the Eastern European countries from an orphanage, where she had spent the first 3 years of her life in a cot, where the only time she had had physical contact was when a bottle was put through the rails of the cot, or when her diaper was changed. And she was on the outside remarkably well compensated for. She appeared to be a very pretty, very well coordinated little girl, until it came to emotional effect, where she did not recognize if she'd hurt herself, she didn't acknowledge it, she didn't feel it. She had difficulty forming attachments in emotional relationships, which for other reasons is entirely understandable. But the most interesting thing I found was that on her draw a person test, she drew a head, a body, arms, feet, and then a space between the trunk and the feet. There were no legs. And her mother said that's how she always draws the human figure. And I thought, well, that first 3 years of her life, she would probably have had very restricted proprioceptive feedback from standing and walking in an upright position if she spent the first 3 years of her life in a cot. So let's give her exercises that involve pushing against things with the eyes closed, so she can't see what she's doing. It's pure proprioceptive feedback. When I saw her the next time, the mother said the most extraordinary thing has happened. She started to draw people and they've got legs. And it was as if that lack of proprioceptive experience had left a blank in the brain's body awareness map. And by putting it in terms of deep proprioceptive stimulation, this had actually started to form. So in her case, hers was the result of environmental experience and could have been prevented. But in those where it's a true maturational issue, I think the most important thing is early recognition and education of parents and professionals working with that child as to how important movement experience is going to be in those first years and continuing, and not to be seduced by modern technology into substituting movement experience with things that keep children happy because they're occupied, like little baby seats with iPads on them where they can sit there and be amused, but they're not getting this stimulation. They're not getting the weight bearing experience. They're not getting the developing control of balance. And we're seeing so many children with poor truncal stability, poor core strength. And I think some of that is a direct result of modern child rearing practices that could have been prevented. So prevention in terms of environmental things that get in the way, yes, but management, I think, is probably where we can do most, is recognizing where a child is not perhaps sitting quite as soon as they should, is happy to sit there and wait for things to be brought to them, is clumsy, and all those issues that we're aware, we're familiar with.
I think I will agree with you when you spoke about the environment factor and modern rearing practices. And I also feel that, the pandemic also has contributed to some amount of, our kids having a lot of dyspraxia also, because isolation and a lot of screen time has affected their going out and playing with others and a lot of movement things. So I completely agree with you when you spoke about environment also contributing to such dyspraxic features. So while talking about research, is there any notable studies or research findings that give some insight into the neurological correlation of dyspraxia and primitive reflexes?
Not that I am aware of. No, as I say, I think this is the big waiting area for future research. And once you've identified the need for this actually would be a fairly easy piece of research to do if you are seeing a large population of individuals diagnosed with dyspraxia. You have the gift in front of you that as part of your assessment tool is to look at the primitive reflexes and see what is the incidence, and are there any specific reflexes that seem to be more prevalent in children with dyspraxia than perhaps in other neurodevelopmental conditions? Or are you seeing very much what I see, which is it's the cluster that's important. It's not one thing in isolation, it's the cluster. And we will never know, I think, whether the reflexes are secondary to the predisposition to have dyspraxia, or whether because the reflexes have not been fully integrated, symptoms of dyspraxia have become more and more evident. The cause and effect is not clear on this at the moment.
I think that is something that even I also struggle with, that question of, is the dyspraxia because of retained primitive reflexes, or the retained primitive reflex because of dyspraxia? I think it's something that we need a lot more in-depth research on, I guess. So Sally, I have like an off-topic question. So you mentioned about this draw a person test, right, that we can use to understand a child's own body. So does that have, so for example, if a child with coordination issues, like, fine coordination, so because the child has a fine coordination issue, the child is not able to draw a human body, a person properly. Do you think that can also correlate to a body experience or a sensory or a primitive reflex
I think
experience?
the difficulty in drawing the figure is not just
Yeah,
the hand-eye coordination. I think it's their own body experience, their body schema is
okay.
underdeveloped or disproportionately developed, and they are actually drawing to the best of their ability how they feel themselves to be from the inside. It is a reflection of how they feel themselves to be. So those that where they have poor fine motor skills, the hands are usually enormous, just as if they feel these are huge, big paddles on the end of my arms. And however hard I try, I can't get them to do these tiny little actions like doing up fasteners and being able to write neatly within the lines and so on. So I think it's both. It's a reflection of how they feel from the inside with a difficulty in the actual representation of the figures as well.
Thank you so much. So I think I can try also in my sessions too, because this is something that I've never tried in my sessions. So this is something very new that I've learned from your interviews. So I can't wait to try it with my children and see how I can help them. So moving back to the next question, what do you think does the nervous system play a role, the nervous system's development play a role in the manifestation of dyspraxia symptoms? And does it relate to primitive reflexes integration?
Yes, I mean, I think it's all part of the same thing, that the maturation of the nervous system, the presence or absence of primitive reflexes at key stages in development are signposts or markers of maturation in the central nervous system. So if there is a delay and we find that primitive reflexes are still active when they should no longer be, they are showing us that that immaturity is present. And that's where I mentioned that from our point of view, they are the key to saying, okay, so yes, we've got symptoms of dyspraxia, but no, it's not surprising we've got some of these symptoms if these 2 or 3 primitive reflexes are active. So let's see if we can work on those, see whether we get improvement in dyspraxia symptoms. And if so, we know whether we're on the right track. But I'll always say to parents, we are only one part of the jigsaw puzzle. You know, that the reasons for dyspraxia are so many and varied cases. That intervention program will be like a miracle. They'll come out and say, this is absolutely fantastic. Look what he can do that he couldn't do a year ago. And there are others who'll say, yes, we've got improvement, but he still can't do this and he still can't do that. And that's where we say, okay, so this has been part of the puzzle. Now we need to look at where you need to go to investigate and try and help with the other part. And I think that the problem with so many of these diagnostic labels is that they are a description of a set of symptoms. They do not explain the cause. Well, at the really beginning of our interview, really, we don't know what that neural signature is. And I heard a pediatric psychiatrist talking at a conference in London many years ago, where he said, if medical doctors were trying to diagnose physical illness in the same way that we as psychiatrists try and diagnose what are considered to be mental disorders, he said they would be taken off the medical register, because we diagnose things like ADHD, autistic spectrum disorder, and so on a checklist of subjective symptoms, which if 2 or 3 people agree in different environments that they've all got the same symptoms, this is the label we put on. And it describes the difficulties, but it doesn't explain the underlying neurology of the causes. And so, sorry, I've lost myself in this somewhere. I can't remember what the question was I was answering.
No, but I think like I agree with you. So the question was, what role does the nervous system's development play in the manifestation of dyspraxia symptoms and the primitive reflex integration? So I think you covered it, because here also we have a lot of parents who come to us and they ask us, what do you think is the cause? Do you think us doing this could have resulted in, having a child with autism or having a child with dyspraxia? Again, this is something even we cannot very clearly say that, okay, this is the main reason why your child has dyspraxia or autism. So I think I agree with what you are saying.
Yes,
Mm.
and as Sally, you mentioned that just one piece of the puzzle is not going to help.
Mm.
There's so many pieces in the puzzles which needs to be put together for dyspraxia-like symptoms or dyspraxia-like label to the children to be helped. So yes,
Yes.
that is what we are trying to do at PlayStreet. I mean, in our organization, we are trying to look at dyspraxia from many perspectives. So
Mm.
we have come up with a dyspraxia program. So there, we are just not trying to do one part of it, but we are trying to see how different professionals can come up together and contribute. See, for example, occupational therapists, they have their own work to do on dyspraxia, which is primitive reflex integration, motor planning, motor coordination. Physiotherapists have their part to play, which is working on the
True.
posture, the balance, the gait. So they basically focus on those aspects. Then speech therapists, they have to work on the sensory motor approach, to speech, because in the end, the manifestation is in the form of the CAS also, which becomes childhood apraxia of speech. What you see is not child not speaking.
Mm.
And then there is two very important components which generally I do not see others doing it, but somehow we have understood the value of it. One thing is rhythm, how to really make a rhythm based music and a movement programs where rhythm is very important, working
Mm.
to develop child's rhythm and co-regulation.
Yes. Yes.
Co-regulation. So these perhaps put together all of these can at least we feel can perhaps could be little beginning steps to
Yes.
to get into that bigger part of puzzles. I mean, that's what like we have understood in in last so many
I would
years.
say the key is
Yeah.
also in the assessment is
Yes.
a really thorough assessment of all aspects, and then looking at that puzzle and saying, now where is the earliest point something's gone wrong? Let's start from the bottom, build
Yeah.
up, and when we get to a certain stage, then maybe the system is ready to start to integrate training systems from higher up. But so often what is done is a top-down approach
Yeah.
is started, and the child doesn't have the roots of the tree and the trunk of the tree in place to be able to integrate the branches that are coming in from on top. But having said that, I don't think there is a single right way. It's looking at the individual needs of the child in front of you and saying, what does this child need? Where do we begin from? Is it going to be one thing? Is it going to be several? And if so, do we do these in a specific order, or can we combine certain interventions at the same time? And it's as individual as the child, really, as to what the answer is. Yes.
Yes. True. Oh,
I
over
would
to you,
also
Murali.
like to add that when you spoke about like for us, when I was doing my masters and bachelor's, so we were taught to do like a top-down approach for a child.
Mm.
Like you go from the performance and then you see what is wrong and then you go down to the cause. But then once I started working with children with autism, and it's been 2.5 years that I've been working right now consistently with children with autism, that's when I realized for some children, the top down does not work
No, it's
because they
too high
haven't
up for them.
really achieved the top skills. It's too much for them. Like when I start giving them like, a fine motor activity which requires a lot of skill, and then I see a lot of tantrums or meltdowns and all of that. And that's when I realized that for most of the children, the top down approach does not work. So we
Mm.
need to start from the brain level, from the neurological level, see where the sensory lies, see where the primitive reflexes lie, where then you go on to your body awareness, your motor planning, and that's something that I think I had to adapt because so far I've been taught like, okay, you need to look at a child from the top down approach. You should not look at the nervous system level. You should look at their performance level. And this was something that I had to relearn, like unlearn that and then relearn the bottom down
Yes.
approach. And that really made a lot of difference. And
Mm.
now the way I view a child, okay, so this is where the problem lies, and I'm able to pick out the issues much better when I look at a bottom up approach.
Yes. Yes.
What we have tried to do, we have created our own curriculum also. And the very beginning of the curriculum, the very first month, we work on body schema awareness,
Mm.
like the understanding of me as a person. So I
Yes, I
think
mean, I
that's
see
where
some.
like
Sorry, go on.
no, I'm just saying that. So I'm resonating to that very much,
Mm.
to your thoughts now, that first, the very first like intervention should start with children knowing themselves, their bodies, the schema, the awareness, and I think that's what we are trying to do, Miracle, right? In our
Yes.
programs, yeah. So, and you have kind of approved it. So, what I want to say is that I'm
You
happy
don't
about
need
it,
my
that
approval.
you have kind of started with your approval. So I'm thinking, yeah, so that's the right direction to go. Yeah. Yes, Miracle.
Yeah, so Sally, we've almost come to the end of the interview. So I know we've touched a little bit on environmental factors. So I want to go a little deeper to see how environmental factors interact with genetic predispositions when coming to dyspraxia. And do you think that affects the intervention targeting primitive reflex integration? What are your thoughts on that?
We have seen over many years empirical evidence that there is an hereditary tendency in most of these neurodevelopmental disorders. And I use the words with care. It is a tendency only. So the law of genetics go down at least 4 generations. And I describe it as being a little bit like a piece of thread that is woven into the cloth in one generation, doesn't appear in the next generation, and then reappears in a different guise the next one down. So there are a whole syndrome of problems like what in modern terms we talk about things like dyspraxia, dyslexia, autistic spectrum disorders, Asperger's syndrome, but also things like a history of allergies, lowered threshold to stress in adults, that they are more prone to becoming emotionally distressed earlier than perhaps other people. They're less emotionally resilient. That this tendency seems to be present in certain families. And as I say, you may have it in one generation and then it'll turn up as something completely different 2 or 3 generations down the line, and then not again. So that can underlie a greater susceptibility or risk factor for children in certain families. And then you have added to that what happens to that child from actually before conception. So in one of my books, it's actually probably the least read. I'm just going to show you. Oh no, it won't help to show you, will it? Because we're doing this on sound. Raising Happy, Healthy Children. I went back and I tried to look at what are the universal biological factors that children need to grow up into healthy adults, irrespective of our culture, our socioeconomic circumstances, and so on. And there is absolutely no doubt that the health of both parents before birth makes a difference. The preconceptual environment into which this child is going to be created. What has happened in pregnancy? Have there been events in pregnancy that might have been enough to trigger a slight underlying weakness that otherwise would not have shown up at all? Has something happened during the birth process? And that could be a very rapid birth. It could be a very prolonged or difficult birth. It could be the need for obstetric intervention, the differences between cesarean section, elective cesarean, and planned cesarean. Each one of these factors in isolation could potentially just tip something one way or the other. But more often than not, when we look at these children's development, we find there's been 6 or 7 factors before their diagnosis that range from preconception, something in pregnancy, something during birth, maybe had an illness involving a very high temperature in the first year of life. By the time you've got 6 or 7 of those factors, the chances are that by the time they're 7 or 8 years of age, a neurodevelopmental disorder, even if it's mild, may actually be present. So we have the genetic tendency, we then have what has happened to that child in their early development. And then we have the avoidable things, things I've already talked about, how much movement experience they get. Do parents realize that just letting their baby have time to play in free space is really important. Being carried by the mother is important because that's partly the beginning of comfort, of empathy, and all those things as well. But equally, free physical space to play, and not just in infancy, but all through early childhood and later childhood as well. That trying not to let your child have long periods of sedentary activity, because this is not training the body. And that modern technology does a lot to entertain children, but it also does a lot to create arousal and excitation in the brain without any physical dispersal of that arousal and excitation. So it creates frustration. It's potentially addictive in the way that it affects the neurotransmitters, such as dopamine. And this is my particular thing, is that one of the issues I have with technology and children is not what it does do, it's what it doesn't do, but also what it does in terms of training how children think. That games and computer programs have been designed by a particular type of mind to think in a particular way, in binary ways and in digital form. And it is my fear that if children spend overly much time engaged in these activities, their own thinking becomes shaped, it's sculpted to think in the same way, which is potentially undermining all the things that children do in imaginary play, when they are creative, when they're bored. Boredom is actually not an entirely bad thing for children. That's when they learn to find ways of amusing themselves, problem solve, think differently, and so on. So again, I've lost my question. But yes, there are potential genetic factors, environmental factors, some of which we can't avoid and we just have to try and manage, and others which we can avoid if we understand why they may affect development. And it's not saying that those things are all bad. You know, technology has benefited us in all sorts of ways, but in using it selectively and not letting it replace the normal development that all mammals need. I think it's the work of Jan Panksepp that I love, where somewhere in one of his books on affective regulation, he talks about how all young mammals need to engage in rough and tumble play, not just because in those games they learn the skills of hunting and chasing and so on, but they learn how to regulate their own reactions in social situations. And that young cubs that are not allowed to engage in rough or tumble play are rejected by the social group as they grow up. And that we should never forget that as humans, we are also mammals, and that we need to nurture the mammalian part of our brain just as much as the executive cortical artificial intelligence part of our brain, to continue to be hopefully a altruistic and empathic species in the future.
I completely agree with you when you spoke about, how modern technology and videos and computer games restrict the way of thinking. Because as it is, I think for children with dyspraxia, they have difficulties in ideation. So when they are given a lot of screen time, it just further narrows down their ideation. It doesn't bring out their imaginative play, or they just see what's happening, or they see a video and then we give a car or a toy and they just try to imitate because that's the only thing they know. I think they're not using their brain to think of other ways, or just like what other ways I can imitate or role play with this toy. So I completely agree with how that can hinder the neurodevelopment of a child and potentially affect the motor development also. This was a very informative interview and conversation. Thank you so much, Sally, for taking your time and getting on a call with us for this conversation. So with this, we come to the end of the questions. On behalf of PlayStreet team, I would like to thank you, Ms. Sally, for taking the time to share your insights and expertise with us today. Your perspectives have added valuable depth to our understanding of dyspraxia and developmental coordination disorder. To our viewers, we hope you found this interview insightful. If you have any questions or would like to share your thoughts about this conversation, please feel free to connect with us. At PlayStreet, we also offer a special program called the Dyspraxia program. It encompasses intensive occupational therapy, speech therapy, physiotherapy, an upbeat program, and co regulation. If you feel that your child has dyspraxia, please contact us for further details regarding the program. Thank you again for being a part of this conversation. Have a great day.